Hello, this demonstration will show how to use NCS to set up layer 2 Q&Q tunnels. In the network, I have a mix of Cisco and PK8 switches. In order to provide Q&Q tunnels across those two vendors, we have specified a generic Q&Q service model where the network engineer gives the VLANs, the edge, trunk and core interfaces as part of the service model. The NCS will then calculate the underlying device modifications and apply those transactions safe to the switches. The simple network looks like this. There's a data center network with two distribution switches, which are Cisco. They are called C1 and C2. I have 4 edge switches, and they are a mix of Pika and Cisco. In the demo, I will set up customer 1 and customer 2 tunnels according to this illustration. So customer 1, being the red one, uses these 2 edge switches, goes to that one, and the green in the similar way. So time for a demo. In the demonstration, I will use the NCS Web UI and the NCS CLI to perform the functions. These can be used interchangeably. Whatever is supported in the Web UI is supported in the CLI, and vice versa. This goes back to everything being model driven, so the device models and service models renders the Web UI and the CLI. In this case, you see the NCS Web UI with a representation of the network. To start with, we would like to ensure that we have the correct configuration represented in the NCS database. So we can start by reading the configuration from the devices, and now it's represented within NCS. From this point on, NCS will perform transactions to the network, so the data store and the network will always be in sync. We can now use the NCS Web UI to navigate down the config. In this case, I'm checking on the PK8 switch P0, and we can check its interfaces. As you see, whatever attributes are supported by the PK8, it's available in the Web UI. The same with the NCS CLI, and remember, the NCS CLI shows the information from the database. It's not a cut-through CLI to the device. So here we have a representation of the Cisco C0 and its interfaces. We can check the Pika P0 and its interfaces. And most important, it's a network-wide CLI, so we go across several devices in one command. So now I would like to display the interfaces across the Ciscos, like that. Okay, let's start by activating the Q&Q tunnel. Let's say we create the customer 1 with SVLAN 444. Next thing is to add the edge switches. Edge switch P0 and CVLANs 13, 15, and we pick the trunk interface and the edge interface. We can continue like this. CVLAN 13, that one, and 15 for that one. That was the edge devices, and now we need to specify the core. And we can pick 1, 1, and 1, 2, and the same here. So at this point we have populated the service configuration, a generic service configuration across different vendors. And NCS has prepared a transaction where we see the information that we would like to happen. Now we have Ciscos and Pikas in the network, and NCS can at this point generate the exact CLI commands to Ciscos and the PK8s. As a network engineer, you're probably curious, what will happen to my network? What are the changes to my Pikas and the Ciscos? And NCS can dry run, so we have an action called commit dry run where we will show the exact configuration changes to the underlying devices at the lowest level possible. So we increase this a little bit. So for the Pika 2, these are the config changes we will make. For Pika 1, Pika 0, Ciscos. So this is the exact low-level change that will happen to the device, and we can now commit it to the network. So now we have customer 1 provisioned in the network, and I showed it using the web UI. Let's do customer number 2 using the NCS CLI. So not only can you display information, you can also of course do the configuration changes in the CLI. So creating customer number 2 with SVLAN 777, and let's set the edge. So we're picking Pika, and we're also picking a Cisco one here. Let's set the core. So this time I prepared the transaction again by providing the edge and the core. In the same way as I did in the web UI, we can do a commit dry run to inspect the changes. First of all, before doing a commit dry run, what are the actual config changes on the service itself? So we can say this is the service we will activate. We will create customer number 2 with this SVLAN and the edge and the core. This is the service configuration. If I commit this, what will happen to the network? So again, here we see the change to the Cisco 0, change to the Cisco 1, etc. And we can commit the service. We can go back to the web UI. And now we have customer number 1, customer number 2. And we see here customer number 1 is using these 3 edge switches. Customer number 2 is using these 2. So this was creating services, but maintaining the complete service lifecycle is complex, like deleting and making sure that all the configuration data on the devices are removed, or changing an existing service instance. Let's imagine you would like to change the SVLAN for customer number 1 and have that applied in the network. So we can go to the service, and I would like to change this to 445. I could as well have done it in the NCS CLI. But now I changed the SVLAN for customer number 1, and the NCS will generate the changes across the whole network. So again, the changes to the edge and the core will be calculated and applied in one go. The change was applied and SVLAN was propagated through the whole network. All of this was done transaction safe. If any of the involved devices would have failed, the whole transaction would have failed. Also, as a user, you can pick up rollback files. So imagine you do a network-wide change and you realize that you shouldn't have done it. You can pick up any rollback file. In this case, I'm picking up the SVLAN 444, and you can load that. And you can apply the rollback to the network. So now we will go back to the previous SVLAN again in one single go. And the CLI, of course, have a representation of all the services as well as all the devices. So previously I showed you that you could configure. Of course, you can inspect the services. So here is service customer 1, and here is service customer number 2. So now you did see that we could manage the devices, the services, and the whole service lifecycle illustrated by Q and Q tunnels. Thank you.